59, find the area of the shaded region in the figure. So we have a circle. We have a central angle of 120 degrees. We are given the radius to be 2. And they want us to find this. This is the area in question. Problem 59 on page 460.
Was that 120?
Yes, 120 degrees. Any suggestions on how to determine the shaded area?
So we take the area of the whole sector and subtract the
That's it. Very good. The area of the entire sector, because I have a formula for that. And I subtract the area of the triangle. I have the two sides and the angle in between. I can find the area of the triangle. Perfect. So the area of the sector, 1/2 times r squared, 2 squared, multiplied by, and I have to be very careful. I cannot plug in 120 in that formula.
Right.
So I have to change it into radians. So it's 120 multiplied by 1 degree in radians, pi over 180. Very good. 1 degree in radians is pi over 180. Minus the area of the triangle. 1/2, or if you want 2 in the denominator. Yes, I mean, you mean side, side.
Yeah.
Side, side. 2 times 2 times. Yes? Yes. When sine is in, when 120 is in sine, you don't have to change it into anything, right? But you just have to be careful and have the calculator in degrees. So I'll do this in one step. So, clear. So 2 squared over 2, so I have just 2 at the top. 2 multiplied by 120 multiplied by pi and divided by 180. And then minus. I'll simplify 2 and 2, so I have 2 sine 120 degrees. 2.4567. 2.45. Whatever measurement unit, squared. And that's the area of the shaded region.
Isn't it 2 sine 120 over?
Yeah. Yes. So so 2 times 2. So I simplified one of them. And I simplified one of them here. So that's why I wrote only 2 times 120 times pi over 180. And then minus 2 times sine 120. Because I simplified the denominator. So this is in whatever measurement unit, units squared, whatever they are. Any questions? Any questions? Should we look at rainbow or we move on? Say it again. Yes. Do we want to look at the rainbow situation or not? Or you want to read it later? Let's read it. Rainbows are created when sunlight of different wavelengths or colors is refracted and reflected in raindrops. The angle of elevation theta of a rainbow is always the same. It can be shown that theta equals 4 beta minus 2 alpha, where sine alpha is such and such. And alpha is this, k is this, is the index of refraction of water. Use the given information to find the angle of elevation theta. of a rainbow? It's a yes or a no? Okay, if we have to think that long, let's do it. So 71. So we have theta equals, did I start this again or not? Yes, I did. Okay, theta equals 4 beta minus 2 alpha. We are told that sine alpha equals k sine beta. We are given alpha as 59.4 degrees. We are given k, which is a constant, index of refraction of water, 1.33. And we're asked to find theta. Okay, so first of all, what do I have and what I don't have? So I'm asked to find this, but I'm given alpha. This is given. So if I manage to determine beta, then I'm in business, right? Okay, so I will plug in alpha, I will plug in k, and try to find beta. Once I have beta, I have theta. Okay, so from here, sine alpha, sine 59.4 degrees equals 1.33 times sine beta. What should I do to determine beta? Yes, in my opinion, this problem should not be in this section. You'll see in a moment why. Good, so in order to find sine beta, I will have to divide both sides by 1.33. So sine 59.4 degrees. I will approximate sine beta. So sine 59.4 and divide the whole thing by 1.33. So I got that sine beta is approximately 0.6472. Ready?
Yeah.
Okay. In which quadrants is sine positive? Yes. Okay. How big can sine be? Maximum possible. Say it again. That's an angle. I'm talking about sine. 1, right? So this is the maximum possible that sine can be. 1. What is the minimum possible that sine can be?
0.
Negative 1. So sine of any angle is between, let's not use alpha, I don't want you to think that I'm talking about that, so I'm going to use gamma. Is always, sine of any angle is always a number between negative 1 and 1. We say that this function is bounded. There is no argument, no x, no angle that I can plug in sine that will give us a number greater than 1 ever or less than negative 1 ever. It's any number between negative 1 and 1. Awesome. Would you agree that this happens with one other function?
Yes.
Which one? Exactly. Not that I care about it right now. I don't. These are the only two bounded functions, trig functions. None of those two can be ever more than 1 or ever less than negative 1. And we know that, right? Because this is maximum possible cosine, and this is minimum possible cosine. This is maximum possible sine, and this is minimum possible sine. Very good. So you already told me that sine is positive in these two quadrants. If this is 1 and this is 0.5, would you agree that 0.64, so this is 5 and this is 1, I'm going to say somewhere here. Okay, I'm going to draw a horizontal line at roughly 0.64. It crosses the graph of the circle in 2 points. And what I am telling you is that there exist two what? Two angles that have the exact, totally different, one in the first quadrant and one in the second quadrant, that have the exact same what? They have the exact same exactly. That's how I determine this height. Looking here. I said this is 1, this is 0.5, this is 0.64. So this height here is how much exactly? And this height here is how much exactly? So there are two, I hope you agree, there are two angles. One with the terminal side in the first quadrant and one with the terminal side in the second quadrant that will definitely have the same sign. Correct? Okay. So I want to find this angle and I want to find this angle. How do I find this? With a calculator. But we haven't talked about the function that I'm going to apply. So that's why this is not the right place for this problem. Assuming I have this and it's 40 degrees, how do I determine the other one?
The other angle.
Yes,
It's going to be 40 minus 1.
exactly, because that's the reference angle. The reference angle has to be the same. If this height equals this height, the reference angle must be the same. Good, so now let's find the first one. So I am telling you that sine of beta equals 0.6472. Which function do you think I need to apply to both sides in order to clear this SIN and just get beta on the left-hand side? Yes, it had. We don't know. That's why this problem shouldn't be here.
Oh, okay.
It's sine inverse.
Okay.
Sine inverse. In order to eliminate sine, I have to apply sine inverse. Sine inverse to both sides. So here's how we do it. I don't know. Sometimes I think it's still on. Yeah, it's max heat. Sorry, Nico. I'm cold too. But at least I'm moving a little bit, moving around a little bit.
It's really warm in the beginning.
I know. I told Phil. Okay, so
What is that?
here is right here. You see it in blue with the second key,
Yeah.
SIN raised to -1, but that's not how we read it. It's sine inverse. Second, oops, I didn't mean that. So second and this, do not delete what you had before for the best accuracy possible. Second and previous answer. I want the calculator to use the whole thing. If I plug it in, it's going to be an approximation. It's going to be an approximation anyway. So now, because my calculator is in degrees, the answer will be in degrees. What if my calculator were in radians? Sorry. Then the answer would have been in radians. So here it is. Press enter. Oh, I didn't do this problem. I don't know. I just said 40 degrees. Sorry. Okay, 40.33 degrees. It's just that that's where I was thinking about 0.64. Okay, 40 degrees. But what is so this is beta 1. What is beta 2? This one is beta 2. This is my beta 1, and this is my beta 2.
I'm gonna say 180 minus beta 1.
Yes. So 180 minus 40, I'm going to say 140. With these two, yes.
So why would the cosecant work? So I was thinking you
What wouldn't what?
cosecant.
Well, you can think in terms of cosecant, but why? We always think in the basic ones, sine and cosine.
Well, you were thinking of trying to cancel out sine, and I was thinking of this as 1 over sine.
Sine inverse is not 1 over sine. If you remember from chapter 2, F inverse. So for example, if I have the square root, how do I kill the square root? Squaring, because I'm using the inverse operation. If I have an addition, I use the inverse operation, which is subtraction. If I have x squared, I use the inverse operation, which is the square root.
Right.
So if I have sine, I have to unsign it, which is sine inverse,
Right.
which
Which
does
is
not,
the same thing as 1
it's
over
not the same. No, it does not mean the same thing. Very good. Questions here? We haven't finished, right? So now I have to go back and find theta. So I have two different betas. I am given an alpha, and okay, and I have to determine theta. What did he say? No. We determined beta.
So you just plug in the B.
From all this procedure, only we determined beta 1 and beta 2. But the question was to find theta,
Right.
So we just put
and we have alpha.
both.
So theta 1 equals 4 multiplied by beta 1, which was 40 degrees, minus 2 multiplied by 59.4. And the other one, theta 2, 4 multiplied by 140 minus 2 times 59.4 degrees. I did write a classwork for you today. You're going to laugh. I hope you're going to laugh. Because you should. Yes, I'm collecting it right now. Just one page. One page. Thank you. Thank you. Thank you. Thank you.